Welcome. So we're about to start. So our presenter is Dr. Cuthbertson. He is the chief scientific officer for Velocigrow. He was an AP chemistry teacher for quite a few years in Bogota and Seoul and Palm Desert and Burbank. Prior to that, he was the senior research scientist at Targacep, where he scaled up drug candidates for human study, resulting in several patents and publications. Prior to that, he was the contract research scientist at Pfizer, where he scaled up drug candidates for HIV, macular degeneration, and cancer, including the successful drug crizotinib. And prior to that, he was at Immucerol, which is where he was a research scientist, and he invented antiviral drug candidates for use in cellular entry inhibitors for hepatitis C virus. And finally, prior to that, at Focal Therapeutics, where he did large-scale synthesis of biodegradable polymers for human implantation. He has a PhD in chemistry from Arizona State University, where he synthesized over 100 novel inhibitors of farnesyl transferase. And tubulin in potential anti-cancer treatments. He also has a BS in chemistry. So please welcome Dr. Cuthbertson.
Thank you for having me. It's a great pleasure to be here, and I always love talking about my research, especially when it has a positive impact on the planet like this research does. The first thing I want to do is start by unpacking the actual title of this talk because it's so long, and some of the words in there are obvious and some of them are not so obvious. Of course, we're going to start with sustainability, and what does that mean in the context of my research? And that is, we're not going to be starting with anything that is not renewable. So we're not going to be starting with any fossil fuels. We're not going to have plastic polymers of that sort in there. And then, of course, if we do start with any plant materials, they're going to be readily renewable. So they're going to grow really fast. It's not going to be like a tree, which you have to wait a century to grow, right? We're going to be growing really fast. And so, for instance, one of the raw materials we might use is seaweed, which grows, it's one of the fastest growing plants on the planet. Next, we're going to talk about vertical farming. Vertical farming is maybe obvious. It's vertical, right? So regular farms are horizontal. Greenhouses are indoors, but they're also horizontal. Vertical farms, they're going to be stacking plants one on top of each other, maybe as many as 12 plants high. And so, of course, that's going to have a lot of different requirements that go along with that. The next is maybe not so obvious, readily compostable. When I started this company, I didn't realize there was a difference between biodegradable and compostable. Biodegradable means that you have big molecules that will break down into smaller molecules. That is maybe a part of being compostable, but it's not the criteria that we need to meet in order to have a readily compostable material. So if you think about what are things that are compostable, I love watching this YouTube channel called Desert Wanderer. I don't know if anyone's seen that. Anyway, the guy wanders out into the desert and he finds these sort of like empty buildings that people built in the Southwest US. And one of the things he finds there is corn cobs, the leftover corn cobs of people who lived 800 to 1,000 years ago. And so if you ask someone, are corn cobs compostable? The answer is yes, right? They will eventually break down. And if you put them in the right conditions, they will break down, but they're not readily compostable in the way that my material will be. So the products I'm working with are composting within 2 months. They're then able to travel or move through a very fine sieve. And then they're proved to not have any negative effects on the plants that you might grow in that compost later. So the criteria means that when you mix this in with regular compost, the plants grow just as fast when you grow plants in that compost. It's a much harder thing to achieve than just compostable. And then finally, natural hydrogel. Hydrogel means it's gonna be mostly water, so we're talking about 97, 98% water. And then natural, meaning we're gonna be starting with like natural polysaccharides. About my company, well, why is that like that?
Click that. Okay.
Click the okay.
No, I can't,
No, that,
no,
that means you're deleting.
it's not on my screen.
You can grab it and move it, though, right?
You can, it's not on my screen. I can't do
Oh,
it.
you can't?
No, that's only on your screen.
Uh,
Then you just say okay on yours. On the blue dot.
Yeah, I guess you hit okay, it's probably okay. Lead meeting is not okay.
Yeah, it's like clicking behind it.
Oh, I
see.
Oh,
Oh, well.
Oh, well, I guess when
You
you
don't
talk
have
about,
to.
you'll just have to listen to what I say.
What happens if you grab the whole bar and move it? Can you grab the whole bar?
No, it won't let me grab anything, yeah, unfortunately. Okay, so, we are commercialization stage. So in other words, we're about to start selling our products. In fact, we're shipping to Amazon, I think this week. So please send us money. Thank you. We are trying to make agriculture more environmentally friendly. Maybe a lot of people don't realize how environmentally unfriendly agriculture can be. I was reading that today, that 70% of the fresh water in the world is used for agriculture. And of course, what happens to that water after it goes through a farm? Oftentimes, it's coming out polluted, either with pesticides or with fertilizers. Not to mention the fact that if the place you harvest that water from can also be damaging the environment, right? In the San Joaquin Valley, I was just noticing that land subsidence is very substantial there. And actually, the San Joaquin Valley, the land is sinking at a rate of about 1 foot per year because they're pumping so much groundwater out. And they're actually drilling wells that are half a mile deep now, right? Half a mile down to finally get to some water. So that's just gonna keep dropping lower and lower. We need alternatives that don't use as much water. And that's what we're trying to do. Finally, our products are helping to improve agriculture. Indoor agriculture has some issues with it, and I'm gonna point those out and how we can help to improve those. So I'm gonna put my teacher hat on for a second, and I'm gonna ask you a question. And the question is, this is a vertical farm. What do you think is required to make this work? Just raise your hand. Yes.
Energy.
Energy, good. Anything else? Yes.
Live,
Light, yep. Yes.
cameras,
Cameras. Why cameras?
because you have to determine how your plants are doing.
Yeah, right, because this guy down here can't climb up there to see what's going on. So some of them are just using cameras alone and they're watching with a human person. Some are using AI, right? They're gonna use AI to determine, does my plant have chlorosis? Does it have tip burn, that sort of thing. Other things that might be necessary for this to work.
Or if I needed to measure water content, soil acidity, et cetera, remotely.
Right, so you're gonna need water monitoring, computer, I'm just repeating it for the people at home. Yes, air, yeah, so the contents of this building are gonna be really important. You may improve plant growth by adding carbon dioxide, for instance, or taking something else out, yes.
A ladder of some sort.
Yeah, actually, right, right? This guy down here can't get up there, and so you're gonna need robots to move stuff around, right? And usually a robot's gonna go up there, grab some plants, bring them down. They're gonna be harvested somewhere close to ground level, right? Great ideas, yes.
Temperature control.
Temperature control. This whole building is gonna be controlled by a massive HVAC system. It's gonna be
Humidity.
very expensive because you have all these lights in there generating a bunch of heat. And not only that, the plants, of course, are respiring, like transpiring. They're gonna be releasing water to the air. You need to take that water out of the air because otherwise it's gonna get really humid in there. Yes,
You need a big warehouse or facility to sustain this amount of crops.
a giant building with a lot of power and a lot of water. Yes.
Conveyor systems to move the plants from when they're infants to when they're mature.
Yeah, right, so you may not be planting the seeds here, you're planting them in a different part of the building that's much tighter, compact, with no light. And then you put them in here for the propagation phase, yeah.
And it's gotta be cheaper than a flat piece of ground.
Yeah, right? So, we'll talk about that. Yes,
Sterilization systems to keep it foreign antigens and stuff out of there.
yeah, we went to visit one of these farms and we had to watch a whole video before we went in the building. There's all these gowning procedures. You see these people are wearing gowns. We kept having to walk through, sterilizing baths. I mean, it's a huge deal to make sure that you don't get pathogens in this building. Anything else? Yeah.
Ready market.
A ready market? Yeah, raise your hand if you buy lettuce from a vertical farm. A couple people, we have 2 people. How do you know? How do you know, right? I personally go buy Taylor Farm salad mixes because they're easy, right? I can make a salad in like 5 minutes. So we need people to be interested in buying all this lettuce. It's lettuce, right? At the end of the day. Is there anything else that I had on my list? Oh, one more thing, and this is gonna be really important because this is what my company does. You have to grow it in something. You have to have a substrate to grow it in. It's not gonna be in dirt. It's gonna be in something else. And so we can talk about how we can make that better. All right, so what are the advantages of this vertical farm? First of all, water. You use about 1/250th of the water that you would use in a regular farm. The reason is there's no runoff. If there's transpiration, you collect that with the HVAC system, put it back into the water. There's no evaporation because again, you can collect it back with the HVAC system. And of course, no runoff. And you're gonna necessarily lose 1 kilogram of water for every kilogram of lettuce that you ship. Because lettuce is pretty much water, right? So you're always gonna be losing that 1 kilogram, but that's about it. What else? You can grow in a regular field about 4 kilograms per meter squared of lettuce per year. We can increase that to about 100 kilograms in 1 meter squared. The reason being that you're 12 high with plants, you have no seasons, you control the light and night cycle. You can control the frequency of light, the intensity of light, you control the temperature. The plants just grow faster. There's no natural pathogens there. Everything's like the perfect environment for them to grow in. So, and because you're taking that seasonality out of it, you're just gonna be growing all year long. And finally, another great advantage is that you could put this in the middle of a city, right? You can put your vertical farm anywhere. It doesn't have to be good land. It can be any land. You could put it in Canada. You could put it in the desert. It doesn't matter, right? But you can reduce the amount of transportation. Yes.
How do you add minerals to the environment that you're growing in?
So yeah, you would buy fertilizer and add it. And of course you would monitor the levels of fertilizer at all times.
Did we talk about how much labor you need as one of the components of?
Actually, I was gonna get to that, but thank you for bringing that up. That's gonna be under profitability, but yeah, that is a great point. So what else? Because we're controlling the environment so well, the amount of pesticide that you might have to use on these plants is going to be greatly diminished. Hopefully it's 0, but it's not always 0, and I'll talk about why. We're gonna greatly reduce that. We can avoid any bad weather. Of course, the weather is becoming more and more unreliable. This winter before last, we had massive rainstorms up in Salinas and lettuce spiked in price, right? Because you can't harvest lettuce when it's flooded. You might lose crops and that sort of thing. We don't have any seasons, of course, inside of our building, so we can grow no matter what. Even if there's a hurricane outside, we're still growing as long as we have power. And of course, as I mentioned earlier, we can optimize everything about the plant growing cycle. Let's talk about what is problematic in vertical farming right now. Pretty much no one is making money as far as I know. The reasons being, when people first pitched the ideas of vertical farms, they thought they would take almost all the people out of the cycle. The thing is, you still need people monitoring the plants. You still need people changing filters. You still need people determining whether the plants are ready to harvest or not. and then actually harvesting them. So actually the amount of people you need inside those buildings is much higher than they ever thought they would be. In addition, oftentimes if you're building in an urban area, of course, the land is much more expensive there. And so that's been challenging. Plus you have that massive building that you have to build there. If it's like a 7-story tall building in the middle of the city, it's gonna cost a lot of money. And then, of course, it's not actually as environmentally friendly as it seems to be initially. The reason being that some of the substrates that they're using inside these buildings are not actually that environmentally friendly. Another disadvantage, of course, is that you need to have the light coming from some kind of light source that requires power. And where do you get your power from? A regular power plant, right? However, if that power is being generated in some dirty fashion by burning hydrocarbons, maybe you're not actually improving things as much as you thought you were. And of course, power is just really expensive. If you do get a disease inside that building, you're gonna have a rapid spread of that disease. If you get, for instance, like tobacco mosaic virus inside your tomato facility, it's gonna be throughout that facility before you know it. And then your entire crop is ruined. So actually maintaining the integrity of that environment is vitally important for vertical farms. And of course, they need to replace their soil with some kind of substrate. And we'll talk about what those substrates have been. So there's basically 3 main substrates that are used in vertical farming these days. The first one is peat moss. Peat moss is harvested mostly from Canada, at least in the US, the peat moss that we use here. And when you do that, you affect an ecosystem for at least 1,000 years. I'll show you how that works in a moment. Peat moss is technically compostable, but it takes a long time to compost, much longer than the products that we're making. And it also can bring with it pest problems because it's coming from the natural environment. So it could have bacteria in it or fungus or things like that. It could even have eggs of different insects so that when you put water on it, they hatch and then they start flying around in your building. Now you have a pest control problem and you have to use pesticides inside your vertical farm, which is not ideal. The next one is cocoa coir. This is actually not so bad from the perspective of sustainability because it's coming from the husks of coconuts. Basically, they just take the husks of coconuts and grind them up. However, it does compost quite slowly. We talked to a vertical farm that uses them, and actually the farmer, I said, what do you do with the cocoa coir after the cycle is done? And they said, actually, I don't know what we do with it. I was like, what? You don't know what you do with it? And it turns out they're just sending it to a landfill. So technically, maybe it's compostable, but they're just sending it to a landfill because it doesn't readily compost. It doesn't go fast enough. So it would actually end up costing them money in the end if they tried to compost it. And again, it will have potential pest problems. They're sort of solving this issue by baking the cocoa coir before they put it in their vertical farm. But that costs money as well. Cocoa coir can also be quite salty. So you have to wash out the salts before you start growing plants in them. Finally, the last one is called rock wool. You would know this as insulation in your house. It's literally the same thing. You're growing plants in insulation. It has no compostability whatsoever because it's made of insulation. And it does have the advantage of having no pests.
So fiberglass or?
It's like fiberglass, yeah, very similar to fiberglass. And then finally, we have our products, which are sustainably sourced, completely renewable. They're gonna compost in under 2 months, and then we have no pests. So we control every aspect of that process. So let's go through those different media quickly. Peat moss looks like this when you go to Home Depot. This is what you see. It comes like, and they say, wow, it makes soil alive and it maximizes water retention. These are all true statements. It grows plants really well. I'm not going to lie to you. It does grow plants really well. However, take a look at this ecosystem. This is what it looks like. So they take a very nice wetland area, a ecosystem that took thousands of years to develop. They strip all the trees off of it. And then they put these grooves in it to allow the water to drain out. Guess what happens during that process? A bunch of methane is released into the environment, which is a very powerful greenhouse gas. And then they start scraping the surface off. And they just scrape that off and sell it to you. And then at the end, they say it will renew itself, right? So then they'll plant some things on there. So they harvest it for 30 or 40 years, and then they have to wait between 1,000 to 2,500 years for that to come back. So I saw an article, actually, it came out 2 days ago from a scientist at USDA saying it was called In Defense of Peat. And basically, the scientist's argument was, well, yeah, it's really bad for the land, but there's so much peatland out there in Canada. We've just barely scratched the surface of it. So there's so much more to harvest, which, you know, may be true. They have barely scratched the surface, but it's estimated that over the next couple decades, the substrate requirements are going to be 50-fold of what they currently are. So imagine 50 times this, which isn't good. And in addition to that, we're just gonna be releasing more and more methane into the environment and creating more and more ecosystems that are ruined for over 1,000 years, which I don't think is necessarily the best way to go. So if we can have an alternative to that, I think we should find something. Cocoa coir, as I said, it was more sustainable than peat, but it can bring with it insect eggs and bacteria and fungus. Actually, when we use it in our farm, we notice that when we put water on it, all of a sudden we have a bunch of flies flying around and we have to use like fly paper and stuff to kill them. It's usually salty, it composts really slowly. So better than peat, but not super good either. And then finally, we have insulation. It can be unpleasant for workers because as they move it around, it will get little fibers in their hands. The plant growth, as you will see when we go visit our farm next door, underperforms greatly compared to the other growing media. So the plants grow like maybe 1/3 the speed. It's made from mined raw materials, so it's a mined resource. So mining isn't necessarily the greatest for the planet. It does not biodegrade at all, so it just goes into a landfill for the rest of eternity. And actually what we found is the vegetables tend to taste really bland too. So you grow these nice looking vegetables, but they don't taste that good. They don't have that sort of earthy taste to them. So just basically summing up what I already told you, we are sort of checking a lot of boxes for potential customers, I'm hoping anyway. So what we have is a sort of gel-like material that we've created. It's compostable. The pH is controlled. Right now, we're controlling it to between pH 6 and 7. We can adjust that as need may be, depending on whatever the species is that we're trying to grow. It will last for up to 8 weeks. What we tend to see is it will tend to dissolve over time. So if you have water running past it in a hydroponic system, it will tend to just kind of melt away, which is fine. And if there is anything left, you just compost it at the end. And then after the nursery phase, it's transferred by robot or transferred manually to the growth stage. So we'll be going then into those very tall vertical farms that I showed you a picture of earlier. Okay, now I'm going to shift gears a little bit and talk about the science behind how we created the products that I'm going to show you. Basically, what this is talking is comparing two different ways of doing research. The left one is sort of like the way you're taught in high school, and the right way is the way that we did our research. Okay, the left way would be like if you had a 5 to 7 component mixture, what you would typically do is hold, let's say it was a 7 component mixture, you would hold 6 components stable, and you would vary one until you optimize that. Then you would hold that one stable and choose another one to vary, and then vary it, holding everything else stable. In order to get the right formulation, you would have to do over 100 experiments, at least. You would have no guarantee of actually finding the optimized solution because many of these things are dependent on each other, right? If I add one of one thing, sometimes I need to add less of another thing. And so there's actually multiple level dependencies that will prohibit you from ever getting the right answer. And then finally, you have no reliability analysis because you don't have a model at the end of it that you can use to statistically model the actual possible formulations. Contrast that with design of experiments, which I'll show you. If you had a 5 to 7 component mixture, you would take between 15 and 30 experiments. At the end of it, you would have high confidence in an optimized solution to the problem. You would have a mathematical model that you could run virtual experiments in. And the reliability of the model could be estimated. So you would actually be able to sort of like figure out how accurate your model was. Yes.
Did you build a digital twin for your environment? Or,
Similar.
use generative AI to create different, experiments?
It's related to AI. I would say the intelligence is us, but the mathematical model is similar to an AI model, and I'll show you actually how it works in a second. Great question. I thought I saw another hand. Yeah.
Does it have to, will you have to vary the composition of the growth medium for every different kind of plant that you want to grow?
Potentially. What we found was we optimized for leafy greens, and that happened to work for a lot of different species. But you could theoretically optimize for something else, like cactus, for instance.
For carrots?
Carrots, whatever you wanted, you would just optimize for that particular species.
You say that hybrid roots is not toxic and best free. Does it meet any criteria from USA?
Does it start with USA materials? No, it doesn't, not at the moment. Okay, so just to use a concrete example for you, I went on the Google and I said, homemade shampoo recipes. And this was the recipe that I found. It was like the #1 hit on Google. So I'm just gonna use this as an example. Is this the optimal recipe for homemade shampoo? I don't know, maybe someone figured out the optimal. But let's say we wanted to make sure that this was the optimal formulation. There was coconut milk and honey and jojoba, castor oil, vinegar, and some essential oil of your choice. So how would you optimize it? Would you use the one variable at a time method, or would you use the statistical design of experiments method? In the one variable at a time, of course, you would just say, for instance, hold everything constant except for coconut milk. Then you would vary the amount of coconut milk until you found whatever that optimal was. And then you would go down the list and just keep going like that. Would you ever find the right answer? The answer is probably not. I took the liberty of converting them to metric because that's a lot easier to see. And then when you use statistical design of experiments, you then must also convert them into fractions. So these are the fractions of a whole. When you use a mixture design, one of the stipulations is that everything must add up to 1, right? That's like what a formulation is. Everything must always add up to 1. So you always get 1.00 at the total. So this is the sort of starting place for your statistical design of experiments. What could you then do with it? So I have this software that I call, that's called Jump. And I input this exact situation into Jump. And what I did was I varied the amount of coconut milk. Let me just point with the pointer, maybe probably better that way. Yes, there we go. I varied the amount of coconut milk by a certain percentage, and then the raw honey, and so on and so forth. And then I have to decide what are the criteria I'm going to use to decide what is good shampoo. So I used hair smell rating and hair softness rating. So you would have presumably people washing their hair with this stuff, and someone would have to smell it and then give it a rating of 1 to 5, 5 being, you know, really good shampoo that smells really good, and so on. And I chose, by the way, I don't know if you noticed, I chose lavender oil because I like lavender. I'm not afraid to say it. I put this into the software Jump, and then I said, create a set of experiments that would vary these results and try to minimize the amount of variance within that design space. So what it did was it proposed that I make 21 different formulations. You'll notice that the levels are all over the place, but the software is smart enough to know that everything must always add up to 1. So in each of these cases, if you went across, they would all add up to 1. So notice though, you're not trying necessarily to make the best formulation. None of these individual trials is intended to be the best formulation. In fact, the best formulation might not be any of these trials. What you're trying to do is build a model and teach the model what is important for hair smell and what is important for hair softness, right? Once you feed those data into that model, then it gives you a valid model that tries to minimize the variance within that design space. Any questions on that so far? Yeah,
In that model, is the model determining the effect, the impact of different materials?
Yes.
On the final product, yeah.
it is. Yeah, it's exactly what it does. And I'll show you how it works with our model. Now, if you're like me, I want to make these, I actually want to go out and do this experiment. I didn't, but I want to do this experiment. And I want to see what the best optimized shampoo formulation is. So if you ever want to start a company with me making shampoo formulations, let's talk, just call me up.
The formula is kind of missing surfactant, right?
It might be, I think maybe the
Yeah,
coconut oil has surfactant characteristics. Maybe,
because I think all of the ingredients, when you mix each other, this is immiscible. And you have to add surfactants like PEG for combat.
yeah, you might be right on that. Yeah. Maybe I could use you as a consultant. Yeah, you're probably right on that. Although I don't know what jojoba, if it has surfactant characteristics, does anyone know?
It's good for moisturizing.
It's good for moisturizing.
Usually I use that for lipstick product when I work with marks. So it's good to have that. But in there, I don't see any ingredient that can create bubble. With that, to have bubble when we do shampoo.
Yeah,
I
yeah,
don't see that in there.
yeah. Okay,
Or
so.
emulsifier, keep it all together.
Yeah.
Let me share my experience. In Vietnam, in the traditional way, the woman is just use the original shampoo, and then they use coconut oil.
Oh.
Yeah, to through their hair, and it's a bit more effect. Right.
Yeah,
They have beautiful thick hair.
I bet that smells great.
Get to meetings.
Yeah.
Yeah, yeah.
Try to understand it, what the model you're creating, mathematical model you're creating is to grow that, to have the substrate that you're looking, or the growth medium that you're trying to develop. So from a standpoint of looking at it from a shampoo that we have no idea what the best shampoo is. However, we do have the best idea of what a head of lettuce is gonna look like.
Yes,
So the impact it will have on this head of lettuce could be easily, because you have a head of lettuce that's been in existence for a long time. You know what it's gotta taste like in order for it to be
yeah,
qualified as. We don't know what shampoo is, but we certainly know what a head of lettuce should look like.
exactly, yeah,
So, so that would be, you have all these mixtures, and then you try it against a head of lettuce, or a number of heads of lettuce, so that you can see what the outcome is. Again, we don't know what the optimal shampoo is, because we all have different kinds of hair and all that other variables. But there's not very much variation in a head of lettuce.
yeah, exactly. And so that's exactly what we did. So we have here, it's in this particular set of experiments, a 5-component mixture. And I asked the software to generate the best set of formulations to make. And what it recommended was 15 different formulations that we then made. And then we basically grew plants in them. So we grew a set of leafy greens in them. After 14 days, we masked all those greens, and then we fed those back into the model. You teach the model, well, you tell the model that you want plant mass to be high. It doesn't know that inherently. You tell the software, we want this number to be maximized, and then it generates a model to try to maximize that number. So what you'll see here in this set of experiments is the first 15 are the actual different formulations that we made. Right? And then the next one after that is called gel control. That is the formulation that my company was making before I started. You can see that that gel control was growing 4.37 grams of plant in those 14 days. Then the software recommended the second from the bottom formulation. It said that if you make this formulation, it predicts that you will grow 40.99 grams in those same 2 weeks. So you're talking about pretty much a 10-fold increase in the plant growth from that first formulation to the refined formulation. Then we tested it. That's the last line here. The tested, we got 41.26 grams. So we pretty much 10 times our growth. Yes.
But there's one there that's 43.8, and the only difference is in the, school.
Yeah.
So why wouldn't you have chosen that one when you, what is optimal about the bottom?
41 versus 40.
Yeah, so what you can do is, you can go into the model and you can put in that formulation, which is number 14. And you can say, what is the likelihood that I will get that number again?
Yeah.
And the answer is, this was probably slightly an outlier, right? Because plant systems are a little bit complicated. So what it predicts is this one over time will be less likely to produce as much plant mass as this one. Yes.
I guess obviously the final byproduct, the final product is gonna be, does it affect taste of that particular product? Is it?
You could
How do
choose
you
that.
test for all that?
You could choose that as a criteria, and then you would have a taste panel and that sort of thing. We did not do that.
How about nutritional value?
Right.
Yeah, you could do that too. Actually, what we found was nutritional value was higher. But it was sort of like an accident, just of having healthier plants in general. Other questions? Yes.
So how do you get the heuristic to actually make those predictions on the right? Were you just using the gel control and its variables?
So I'll show you. This is a graphical view of the same thing. I can sort of skip over that. What I want to do is switch to a different program. I actually have the software running right now. Can I get it onto there? I'm going to share a different screen, I think. Sorry. Sort of my first time with this.
You're not on the screen.
Well, our home people can see.
The whole people can see. I got part of it right. Wait, I think I do this.
Get out that phone and log in.
Let's see. Oh, I want to mirror. That's what I want to do.
So I assume are you implemented in like SageMaker, I would assume?
Okay, so there's the actual model that was created from this. So what you can see is, what the software tried to do was create a model that minimized the variance throughout the design space. And what it was able to do is very closely align the predicted values with the actual values. You can see the R squared is 0.9, and then the p value is much less than 0.0. It's 0.0001, but even lower than that. Yes.
So I was just curious, from a software, are you implemented in SageMaker or custom tensor or something like that?
I don't know any of those words. Yeah.
What language do you speak?
Yeah, this is jump software from SAS. Yeah, so what you get is, someone had asked about the effects of different ingredients. Yeah, you did. So this shows you the effects of different ingredients. So the ingredient that had the largest effect on product quality was the water. The second was carbon, and so on and so forth. So it actually gives you an effect list, if you will. It doesn't tell you the direction of the effect until later. But then when you go down to the bottom, what you get is what I was trying to tell you about with these models. So you get the dependencies of everything on everything else. So plant growth increases anytime you have a positive slope. Plant growth decreases anytime you have a negative slope. And of course, if I change one, I change the others too, right? Because everything's dependent on everything else. So this is why you get a more reliable model at the end of it than if you did one variable at a time. Now, I told the computer program that plant growth should be maximized. And so if I go to here and I say maximize desirability, it's gonna know to maximize the plant growth. And I do that, and it tells me if I make this formulation that I'll get the maximum plant growth. Now, some of these things are really counterintuitive. For instance, if you look here, M&S, that's fertilizer. If I increase fertilizer, I actually decrease plant growth. That's not something you would have predicted before you did this set of experiments. If I add carbon, for some reason, the plants really like carbon. There's a very strong positive correlation between plant growth and adding more carbon. And then calcium citrate, they just hated calcium citrate. You can see a very negative slope with calcium citrate. Now, the cool thing is you can run what if scenarios as well with this. Did you have a question?
Yeah, what, is it a plant specific?
This is specific for the 5 plant species that were
Five.
tested at that time.
Okay,
We found out later that it actually worked for a lot more species.
okay.
Yeah,
And then can you control for things like you get plant growth, but are you getting leaf growth as compared to
you could
stem
do all of
growth?
that, yes.
Okay,
You could do all of that. You could maximize fruiting or the germination rate or whatever. Mhm. And you could also do other things, let's say let's say carbon was really expensive to me and I didn't want to use that fraction of carbon, I could then reduce it to some different amount. And then I would click on here and lock that factor setting. I said, if I was only willing to put 0.0026 carbon in, what's the best formulation I could make? And then you would go maximize desirability again, and it would tell you to make this formulation if that was as much money as you were willing to spend on the carbon. So that's why this is such a powerful method. Yes,
Do you need to have a database for the software to know, oh, water is the most important component in your system?
all I input was what you saw on that previous screen was the list of the plant growth numbers, and then it figured that out itself. It figured it out that it had the biggest effect when it changed the amount of water. Yeah,
So let's make sure we have time for the tour.
yeah, so I should wrap it up. Okay,
How long did it take you to get all the data in order to feed this model?
2 weeks.
Oh, not bad.
Yeah, plant growth was 2 weeks, and well, we had to make the formulations too, so maybe another week, 3 weeks. Okay. I don't know if the people at home can see this now, can they?
yes.
Not
Oh,
that,
for that-
you go back to where you were, I guess.
Yeah.
You can find your way back.
It's like a labyrinth. I taught online for like 1.5 years because of COVID, you know? I don't really miss that. Trying to navigate through this stuff.
Yes, it's there now.
Okay, cool.
So besides leafy plants, have you tried like, beans and things like that?
We've tried a lot of things. In fact, I have a screen.
Oh, there we go.
So we then tested it against all these different things. So you can see we have cilantro and basil and different mixes, like we call elegant mix, which is like a mixture of different greens. We have bell peppers in there, broccoli. What we found was, generally speaking, the germination rate was similar. Sometimes we exceeded, but usually it was similar. And then plant growth was typically higher. So that was just for that particular formulation. So we maximized it for leafy greens, but it just worked for a lot of other stuff too. And so we've also tested it against these other things. We've got flowers of different types, peppers, cucumbers, grasses, a lot of things. Pretty much the only thing that didn't work was corn. Corn didn't like our stuff, which doesn't matter because no one grows corn indoors.
You're right.
All right, I'll just move quickly to a couple of the products that we've developed. So this is one of the products that I wanted to show you. I'll just pass them around. This is a sort of very low density growing medium. This is actually a lower density than any of the other competing media that you saw on there. And this will become a gel, basically. So what you'll do is soak this in water for like less than an hour. It'll become a gel. It'll become like 98% water, and then you just grow your plants in it.
And it's not a biological product, this is, what's this made out of?
It's made of
CNC.
polysaccharides, fertilizer, carbon.
Okay.
Yeah,
What about the half-life of hybrids?
I'm sorry, what?
The half-life of the hybrids.
Oh, heck, how long does it last?
Yeah.
A couple months. Yeah, a couple months. You got a question?
Yeah, how long would this last for? Until it would be evaporate, or I guess.
It depends on the watering system, right? So some watering systems have faster rushing water than others. In those cases, when it's a fast rushing water, it will tend to go away over a couple months. In other circumstances, like we actually put some outside, you'll see when we walk over. It's been there for like 4 or 5 months, it's still there. So yeah, it can last quite a long time. We also made a liquid version, I'll show you when we go over there. And then we have, the last thing I wanted to show you was what we call FT. And this is the sort of medium density version that will be on sale at Amazon next week.
Did you put a seed in here?
Yeah, you just put a seed in here and water it with like regular fertigation solutions.
Oh, wow.
This feels easy.
This is kind of like a fruit leather type of material.
So why is it wet and the other stuff was dry?
So this is a lot easier to make. The other one requires like a freeze drying system. This I can make with a secret way, but it's a lot easier.
So is that the same, you can grow the same amount in that little one as,
So yeah,
Bigger.
these little ones are for growing lettuce. Those bigger ones would be good for say like cannabis or bell peppers or something like that.
And then you then plant it in regular soil, what happens, this is the germination stage, right? So what happens the next day?
Okay, so for a lettuce, this little one, what you would do is you would do the germination. And then you would then move it on to the propagation stage, and the entire lettuce plant would grow out of this. So you would get a full head of lettuce in about a month
so you can
from
put
this.
it in anything?
It would be sitting in a watering system that I'll show you next door.
So that provides the nutrients as well as the substrate.
It does have some nutrients in it, but most of the nutrients are gonna be provided by the hydroponic system. But we find this gives them like a head start,
Yeah.
and then like the other media never catch up to this one.
So
You had a
that's-
question?
Yeah, so when that's actually growing, does it volumetrically change, and does it stay that volume?
Pretty much the same. They tend to shrink a little bit, but not a whole amount. What we try to do, one of the models we did statistically was to minimize shrinkage. Yeah,
Do you still need those little cups that go in the hydroponics?
sometimes you can use cups for these to hold them so they don't sink. Or depends on the water system.
Yeah.
Yeah. Yeah,
What does FT stand for?
freeze thaw. Yeah. I freeze thawed them. There's something called syneresis in hydrogels. When you freeze them and thaw them out, they just lose water. So if, like, what's a good example of that? Jello, I think if you froze Jello, it would lose water. Okay. So, finally, ours is the only growing media that I know of that is certified by the Biodegradable Products Institute as compostable. In order to reach certification, it had to disperse within 12 weeks. It could not contain any fluorinated compounds, so they analyzed it for that. It could have no synthetic carbon. So all the carbon in there is natural, even the carbon black that's in there is made from trees. And the compost is beneficial to plants. So at the end of the cycle, you couldn't hurt plant growth with the compost that you produced from our product. Right now, even though we're a company of only 6 people, in fact, 2 of them are only part-time, so we have like 4.5, I guess, 5, I don't know how you quantitate that. We have 15 products in development, and the reason is that the statistical design of experiments method that I told you about. And I just wanted to thank Oakcrest for hosting our company in this building next door, for hosting this presentation, giving up their space for us was very nice. I'd like to thank you for attending today. I'd like to thank my investors for believing in what we're doing. We have all venture capital money right now. And after this, after your questions, I'll bring you over and show you the actual farm so you can see what's going on over there. Any questions for me?
So this what's going to Amazon this week?
We have 4 different products going to Amazon. We have this one, a different size of this. We have the liquid feed, and then we have another one that looks like regular potting soil. The other one that I handed around, we're not quite ready to sell yet.
So what do you do the liquid feed?
Liquid feed's very simple. You just pour it on just like any other.
It's your basic
Regular
fertilizer.
potted plant and
Yep, yeah, so it's basically a concentrate. You're gonna dilute it. Actually on the back, there's like a dilution table. And you'll dilute it according to what stage of plant growth you're in.
would that promote, what kind of plants would that promote growth?
It's working on everything.
So do you?
It's working, I use it at home. It's crazy.
But that,
I'm not kidding.
so that you could use on dirt.
Yeah,
A regular
Okay.
pot
you can use
plant.
it in a field, you can use it indoors. It's completely non-toxic. Everything is food grade. You could drink it if you wanted to. I don't recommend it. Yes.
Who do you anticipate your Amazon market will appeal to most? Is it the cannabis market that's gonna grab this?
I'm
first?
kind of hoping that what happens is growers at actual indoor farms are like, what is this stuff? And they buy it and they try it out and they like it. And then they come to us and say, I want to buy like 10 million of them. That's what I'm
So
hoping.
you think the farms are gonna do it, not the backyard cannabis growers?
Well, I don't know.
Okay.
We'll just see.
You need to get Beyonce to go to your next.
Yeah.
Or Taylor Swift,
Yeah.
one or the other.
Yeah.
Do we have any local farms that are wanting to deal with this right now? Or-
So we've done trials in like 20, 30 farms, something like that. And everyone who's used it has liked it, I think, except for like one.
But any local ones that we visited or?
Yeah, I can't tell you who, but we had a major farm in town that was interested.
How did you go from, not all big pharma, because it was varied, but teaching, and then how'd you get into this? How'd this happen?
Okay, so like, I used to work in the biodegradable polymers before I got my PhD. In human implantation polymers. Basically, they were used as sealants for different tissues inside the body. When I interviewed for this, I saw a polymer job open up and I applied for it. And then I told them, you know, guys, like, if you're not doing statistical design of experiments, you have to be. And I sold them on that idea. And then within a couple months, I had sort of like fixed all the issues. And then they wanted to promote me. That's kind of how it worked out. Yeah, so.
When using the liquid concentrate, is there any irritation to your skin?
No, it's totally fine. Like, it's pretty much the same stuff you would put in food. Yeah, you could literally drink it. It's probably kind of salty, but
So is this a byproduct?
I haven't tried
of the growth of I don't know what.
Polymer medium?
Yeah,
the liquid feed,
yeah,
oh, the liquid feed is a completely different formulation using a different polymer.
right.
And one day I was just like, I wonder if this would work, and then we optimized it using statistical design experiments, and it worked, and literally I could show you in the back, we have probably 10 to 15 different species of plants out there. All of them are benefiting from this product.
Wow.
Yeah, and it's market difference.
And then so you could patent that, so Miracle Grow could.
Actually, I don't know if it's patentable. We're just right now keeping it as a trade secret.
Yeah.
But yeah,
We've got a question from
Oh.
our visitor. Kim is asking if there are certain areas or cities in the United States or other countries where vertical farming is more viable financially as well as plant growth.
yeah, so they're finding a lot of success in the East Coast. The main reason being that pretty much all the lettuce is grown in California. So shipping it out there, by the time it gets there, it's old. It's expensive, it's got a big carbon footprint. So vertical farming in the East is very desirable. Of course, any cold climates, you know, if you wanted to grow have fresh salad in the middle of winter in North Dakota, where are you gonna go, right? So you can get it there, it's just not going to be the best freshness.
So all these empty malls can have pickleball and vertical farm.
That's a great idea. You need a place with a lot of power and a lot of water. Yes,
Yeah, a lot of the, like the biochar stuff that's coming out is getting criticized because you're kind of just passing the sustainability to the next person. So like your chemical manufacturer, do you guys have a way to actually ensure the person who's producing your ingredients is sustainable?
we should, we don't. But yeah, that's a great point. That's a great point. We haven't done a cradle to grave analysis. Yeah, I think that's something we should do. And we do have a version, by the way, that doesn't have any carbon in it, any carbon black in it. I mean, there's carbon in it, obviously. But yeah, this version also works.
So it's just for what people prefer that appearance.
Yeah, we didn't get quite as good a plant growth with this version. The plants do like carbon, as you saw in the statistical model. Yeah,
So want to break for the tour?
yeah, I'm ready to go for the tour.
So bye online audience, we're gonna go do a tour. Maybe we can arrange a separate private tour for those that are online and want to see the actual farm.
Thank you.
Okay, thanks.